just say if for other case, if the bearing want to fix that position, normally.
Oh, because
Yeah,
of
it's
the
like-
clearance
okay,
of
yeah,
that,
it's like-
clear step.
the step,
Yeah.
this one,
Yeah.
this,
Yeah, this one is
fillet.
like just like.
Yeah.
So, well, what radius do we have? I mean,
But I think maybe for this case, maybe they you just provide this calculator, so maybe nothing in practice.
We can use, do we need the bearing dimension? Depth,
so you've got,
fillet,
what do you mean by
the bearing that we selected.
yeah, I'm just trying to find that. Do you mean, what I'm trying to find is the, these are the tolerances for the Y bearings.
But how is it the?
What we need to know, what is it we're trying to work out? We're trying to work out what is the, I mean, I think it's likely to be an undercut, as you say.
Then we
Or something,
decide R.
we just don't know what R is,
The maximum R.
because it's not actually a fillet. It's not, there's not a radius there. We actually want the shoulder.
Just yeah. So we should not bigger like these because we need to show that they have
Five, we need to
we
have
have 5
bearing
meter, 5
against
that.
Sorry, and they have,
Only 5 is 25. So
Yeah, so
Yeah.
maximum is 5 anyway.
yeah. So but we also need the shoulder. So
Smaller than 5.
yeah, we should very small.
well, you should, the point is that, so I'm not sure the camera's going to get the
5 is
thrust
the
of
maximum you can go.
Well, no, because it's not a shoulder
Yeah.
then, the bearing can't go up against the shoulder.
Exactly, yeah.
So what Leanne's saying is that they have an undercut there, so they make sure that essentially the bearing goes flush up against the shoulder. Yeah? Is that if I understood that
I
correctly?
think it's one other.
That's one way to do
one
it.
other
Or
thing.
we can put a
Maybe-
spacer here, or you can put the bearing further away from.
No, bearing also can go to the shoulder. Just like
Mhm.
it's very small. Maybe it's just a little bit below that.
Yeah,
But
just
bearing
tiny.
can also can go this way.
Yeah.
Because, yeah.
But what we're wondering is what does that do to the radius here?
Yeah, just whether you want to really just strong or not.
Yeah, I mean
Yeah.
essentially as the radius gets smaller and smaller as it goes towards 0, you can see the stress concentration factor shoots up.
Yeah.
Yeah. Now what we have
Okay, let's
the larger diameter upon a smaller
1.4,
diameter
somewhere here.
is that we have 1.4, yeah?
Yeah.
Yes.
So somewhere on this curve.
So 1.4 times the small diameter, which is 25, about 35.
It's R. No, it's
That's
R.
R.
Yeah, so
But this is when R is
will be-
infinitely small.
what is
The
R will
radius
be
of the fillet is infinitely small for what we're doing.
if we want, yeah, calculators.
1.4.
But it shoots up here because it gets smaller and smaller because R's tiny divided by something. So it's going to be,
Very small.
it's going to, I mean,
Oh yeah, because it's 25, so it's here.
I
Will
mean
be what
So
is R will
if
be.
it's
If
like
we
about
here,
0.14, right?
what R will be.
25. It'd be 3.5.
That's
sorry, if it's
3.5.
It's 3.5 radius. If we aim for something like
Here.
a stress concentration of about 1.55.
but we can't, so the bearing won't go up against the shoulder.
Can we check what's the clearance on that?
Yeah, I think that's enough. I can't seem to find another. Just bear with me, I'm back on the SKF website.
No, the PDF doesn't show that.
PDF doesn't show that. I mean, you can see that there's very little. For the Y bearing, there's very little. And
So it almost needs to
shaft
be-
tolerances, see text. Okay, we might have. Just bear with me to see what that. The shaft seats for Y bearings with globe square centric rocking collar should be machined to H. For Y bearings on an adapter sleeve. For Y bearings with standard in-ring, the same recommendation, standard decoupable bearings, e.g. tolerance J6. The location of most commonly used RSO tolerance based components is also tolerance tape. I think that's to do with just the shaft diameters. We want to know what's the tolerance against the shoulder.
So it doesn't say.
I suspect that the stress concentration we have there isn't what we're after.
But yeah, what dimension of that?
That's what we need to know, yeah. How did they arrive? So I'm not convinced we should be looking at that.
Just looking at how they
Yeah.
got information from. Doesn't make sense.
Can we find it through the SKF website? Is one thing.
Yeah, I think we can see how that is.
Okay. So this says for the wide bearings, the shaft tolerances. Under normal operating conditions, the shaft seats for wide bearings with grub screws or an eccentric locking collar should be machined to a H7 tolerance. What's an eccentric locking collar? I mean, so we can put an adapter in or some spacer, so the spacer could be machined to fit the radius.
Then we can get away with a thicker radius.
Yes,
If we want.
is one way of doing it.
Mm.
Do you want to do it that way?
We can do it that way.
It makes it
But-
quite expensive because you have to machine in radiuses into a spacer and things like that.
But
It's a standard part.
we would. Do we need to recalculate? Because then the position of the bearing and pulleys are
Yeah, we're starting to
away
confuse the
from each
issue, aren't we? I mean, what my own personal feeling is it just essentially go as close to 0 as we can here.
Yeah.
And we just say where's the highest it goes, and essentially it goes to 3, it doesn't go beyond that.
Mhm.
Yeah, you can see it's not converging, it's not asymptotic to 3, but that's,
But that means it will go forever.
yeah.
So we can't go.
We need to know what value of R we can take.
Mhm.
Now my suspicion is we just say, what's the manufacturing process, what does it give us?
Mhm.
And I think 0.5 millimetre, 0.4 millimetre.
Okay. Should we say 0.4?
That's a guess. I mean, let's see if we can find.
Our
Can we
small
find something?
diameter is 25 with 0.016, which is
So bearings on adapter or
Yes,
withdrawal
yeah.
sleeves, snap ring, groove and outer ring, temperature hybrid, flange and outer ring, extensive bearings.
our stress concentration is only at 2.6.
Doesn't really help us there. It's an SKF bearing, so what was that?
It would have been like 2.6.
If we have the, okay,
0.4.
0.4 millimetres. Should we just go with that and put that
Yeah,
down as an
I think so.
assumption? Yeah.
Okay.
You happy
So
with that?
are we sure that 0.4 will clear that bearing?
There is nothing that I can find in here that tells me
No.
in the SKF website. It says seals, dimensions, tolerances, radio internal clearance.
Emissions.
I've already had a quick peek at it, but this
Yes.
says internal clearance of wide bearings. I don't know what they mean by radio internal clearance. I'm assuming that's
That's bore diameter, but there's no mention of fillets or something like
no. I mean, essentially what we want to know is what sort of shoulder can it go up against.
Yeah.
Mounting and dismounting. What does that mean? Hexagonal key, hexagonal size of grub screws. Hexagonal key tops to grub screws and eccentric locking collar. Expansion of size of smooth lock. No. That's not what we're after. So we've got seals mentioned in tolerances I've looked at previously. So we've got the symbols, nominal bore diameter, deviation of the mean bore diameter from the nominal. Nominal outside diameter, I mean essentially saying what's the variation in. Doesn't tell us what. I mean, I think some of these perhaps aren't meant to go up against the shoulder, because they have grub screws, but grub screws are really not particularly good ways of actually locating something. I mean, in fact, they're pretty dreadful.
Yeah. This was our range, wasn't it?
Yeah.